We'll see. Any questions with respect to the assignment?
Yeah.
Okay. We continue with chapter 3 of levels. So today it's about reading data, which is of course the first step. If you want to do something with data, you first have to get data. So reading data from all kinds of files, file structures. So we start with just the comma-separated format, CSV files, which is just an ASCII text file. So we start with just importing pandas, and then make sure that every variable also has single line as shown in the output. And then, what? Yeah, so they are on canvas, and it's in a zip file. So let's have a look. So it should be. Let's see, week 3. So it should be here, according to
Introduction.
that is
Obviously, it's correct.
chapter 6. And data.
But I think it's very useful for my work.
So it's a zip file because there are a lot of data files in the folder, the examples there. And what you also see is there are 2 versions, one with underscore win of Windows and one underscore from original. Because the author uses Linux, and there's a similarity between Linux and the Mac OS, but there's a, let's say, difference between the Mac OS and Windows. Yeah, so if you have a Mac OS or Linux operating system, you can open the original file, and otherwise you can download and open the Windows version. So that's over here. This is the reason why there's a difference, because if you use a Mac or a Linux, then you have to use this cat command. Yeah, so this cat just shows you the content of an ASCII file. So in this case, we see the raw content of this CSV file. So CSV stands for comma separated file format, and we indeed see that all the entries are separated by commas. So in this case, we can use just the read underscore CSV, and this reads in the data into data frame. There's also a second, which is almost comparable. So we have the read CSV method, but we can also use this read underscore table. And the read underscore table uses a space or a tab as a separator. And therefore we have to specify that the separator in this case is a comma. Yeah, because it's a CSV file. So you can either use read underscore CSV, which as default has a comma as a separator, or you can use this read underscore table, which reads general ASCII files, and then specify the separator using comma. So this gives us this leads to the same data frame. So the second one is a file which doesn't have column names. So you can see over here that the first row is used as column names, and in this file the header is removed from the file, and we just start with the raw data. So you can see over here, we can use header, the option header is none. And we can also specify the names then. So if this is, if you execute the first one, we'll just get the default names, which is just numbers. And if you just want to have these column names, we can specify it ourselves. So that's over here. So this is the first one without specifying the column names. So it just starts with 0, 1, up to 4. And then the second one, we specify the labels of the columns. And we just have the A up to B and the message. Well, we can also specify whether something is a column name or an index name. So in this case, we have an index name, which is then the message column, and then the message column is used for indices. Now what's this? Over here we have another CSV file, and in this case we have a double index. This is also called a hierarchical index. So this means that we have two levels of indices, one top level, which is more general, and then a second sub-level. So that's over here. So this is then, here you can see the hierarchy. This is the top level index, 1, 2, and within the top index we have a second sub-index. A until D, A, and A until D. Yeah, and you can then summarize this in tables in which we, for example, summarize with respect to the top level or the second sub-level. And this, we'll see this in another chapter. Then let's have a look. This is another file. This shows us the raw data. So this is line by line. So we see that indeed each line is ended with the new line. And here we use the read table. So this is the general method to read an ASCII file. And here we use the separator, which is now the \s plus. So this means that this is a regular expression, and we will see some more regular expressions later on when we want to interpret an HTML file. But over here, this means that this is just an indicator of a space. So \s stands for space, and the space could either be just a space, a regular space, like you have when you press the space bar, or it could be a tab. So if you use the tab key, this will also be recognized as a space. And here we have a plus, so this means that we can have more than one space. And so it could have 1, 2, 3, 4 multiple versions of space. Because over here we see that there is no minus sign. Therefore we have two spaces, and if we have a minus sign, then there's only one space. So if we use the space as a separator, then we read the file as shown over here. There's something else. What we see over here is that we have 4 columns, and that the first one is the index. And therefore, over here, there are only 3 column names, and then Pandas automatically takes the first column as the index, because it doesn't have a name. So this is the first column. Let's see. Sometimes you like to skip some rows. In this case, we have over here a file, and this file contains some comments. Yeah, and we don't want to read those comments, and these comments are on the first, third, and the fourth lines. But of course, Python starts at 0. So this is 0, 0 line, and the second and the third line. So these 3 lines will be skipped, and then the result will be, data frame which we want. Sometimes the file contains missing values, and these missing values are either indicated by, for example, NA, or just an empty string. You can see over here that on the second and the third line, there are 2 missing values. And this is indeed, if we use this is_null method, we actually see these 2 missing values. Missing values could also be indicated by Sentinel, so that's just, let's say, a code. So in this case, if it is a null, let's see, if it is a null, then it should be a missing value. Is there something different? I don't see any difference between these 2. But here, there's something else going on. Here we specify a missing value for each individual column. Yeah? So we have the column message, and if there's a message either element full or not available, then this will lead to a missing value. And for the column named something, the 2 over here is interpreted as a missing value. Yeah, so that's over here. We see that something 2 leads to a missing value. This already is just an empty string, so this remains a missing value. And for message, we now also have that the last line is also giving us a non-available missing value. Now the next thing is to read a text file into pieces. Well, what's the idea? The idea is that we have a data file which is huge. So in this case, it's not so huge, but it is it's for the purpose of illustration. We have 10,000 rows. We have a file with 10,000 rows, and what we like to do is we want to read the data in parts. In parts of 1,000 lines. So if we have to run through the whole file, we are cutting it into 10 pieces, and then we can first read the first part, then the second part, until the last part. Yeah. So what's the usage of reading in sequentially? So why would you want to do this? Well, if your data file is larger than, for example, your internal memory. Yeah. So if, for example, this is 128 gigabytes, and you only have, let's say, 8 or 16 gigabytes, yeah, then you can't read the whole file into your internal memory. So what you can do is you can read in chunks of information and then somehow sum this information. Yeah. So that's also the idea over here. So we have 10,000 rows, And we are interested in the frequency of all the keys. So the keys are in the last column. So these are letters, and we want to know the frequency. Now, let's have a look. What's this? So these are just the first five lines. So we see the L, E, G, R, Q. And now we telling Python to make an object in such a way that we can read 1,000 lines. And then over here, for each piece in this chunker, we read the data, then look at the value counts. So it's the value counts of the key. So the key gets the last column, then the value counts. So that's, for example, A is 5 times, B is 10 times, etc. And then we add this to dot, which is pandas series. Yeah? And in the end, what we get is the frequency of all the letters, and this is then the top 10. Okay, so we see that E, that's most frequently encountered as a key, then the X, L, O, Q, etc. Yeah. So what we can do is we can increase the chunk size, let's say to 2,000, and then we can actually print, let's say, all the value counts of the pieces that is in this particular piece, and then let's say the first, the top 3 values. Let's have a look. Yeah. So over here, what we see is the top 3, but now not for each 1,000 lines, but each piece of 2,000 lines. So therefore, we only have 5 pieces. 1, 2, 3, 4, 5. Yeah. And this is top 3 in the first part, top 3 in the second part, etc. So in the first part, in the first 2,000 lines, O occurs 92 times, F occurs 77 times, and X occurs 77 times. In the second piece, so the next 2,000 lines, the X is the most frequent key. Yeah? So we read chunks of data, and then by adding it to our previous information, we we look at the total. Yeah. So, for example, if you would be interested in the mean, the sample mean, how would you calculate the sample mean? Well, you could calculate the sample mean as 1 over n, and then x1 up till, let's say, x10, if we have 10 parts, 10 pieces, and x1 is then the sum over all the observations in the first 1,000 lines, in the first piece. Yeah? So the only thing we have to do is add all these numbers together and then divide by 10,000. Yeah. So this is just a simple example, but you can imagine that if you have really, really a lot of data, which cannot fit into the internal memory, that this is one way, or this is actually the only way to calculate some statistics. Let's have a look. Yeah, so sometimes we read data. Now, how to write data? That's just using this 2_CSV method. So this is our data frame, and now we write it to a file, and we can see the content of the file. Yeah, so we see that the index over here doesn't have any label or name, column name, and then we have the column names, and then on the second line we have all the data. We could also use another, so this is CSV. So CSV is a comma separated file, and therefore the default separator is just comma, and we could also use another character to separate the data. So in this case, it's a vertical bar, and we could also, for example, instead of having empty strings for a missing value, we could also specify the string for a particular missing value. So in this case, this empty string is then replaced by the string null. You can also write the data without a header. So this is without the first line showing the names of the labels. And in this case, there's also there's no index, but the index is false. This is a somewhat more elaborate example. In this case, we have a data range from that starting at the 1st of January 2000, 7 days, so the first week. Each day of the week contains the iterative number. So we start at 0, then 1, 2, etc. And then this is written to a file. Okay, working with the limited formats. Let's have a look. This is if you. So this is a more lower level idea of reading in a file. If you have a lower level, then you just go through the file line by line. Yeah? So first we have to open a file. So this creates a pointer to a file, and then we read the file line by line, and then each line can then be interpreted. So let's have a look. So now the lines are a list, and we have first. We want the first line to be headers, and then all the other ones to be values. And then we can use this zip, which combines each header with a value. So this gives these tuples over here. So these are ordered lists. So this is a dictionary in which we have the keys A, B, C. So these are the column names, and then each key has then two values, which are the data. So this is a somewhat lower level idea of reading a file in which you go through the file line by line. There we also have this JSON format, and this JSON format is the JavaScript object notation. And this JSON file format is usually the file format to communicate with a web server. Yeah? So if you access an HTML file or something else, then usually the data is transported using this JSON file. And this JSON file really looks like a dictionary. Yeah? So over here we have the curved brackets, and over here we have the keys and then all the values. And within a particular key, we can have a list, which is over here. And this list also consists of a dictionary. And this dictionary itself has mere as value as keys, which consists of lists. And so this is a combination of dictionaries and lists. This is a dictionary. Then JSON dumps puts this into something which we can use as a data frame. So this converts the JSON file, this dictionary, into a data frame, and from this data frame we can access information using this dictionary like methods. So from the results we want to have the siblings, and from the siblings we see that we have names and we have the age. So in this case we have two siblings, Scott and baby. So the JSON dumps converts a JSON object into a data frame, and the other way around is let's have a look at this. This is just an example how to read a JSON file directly into a pandas data frame. The next has to do with web scraping. So usually there's you can scrape information from the internet. So in this case, it's just an HTML file, and this HTML file is interpreted by either Beautiful Soup or some other interpreter. I will not go into details, but we will spend 1 week to web scraping. So this is only to show you that you can easily. So this is just an HTML file, and we can convert it into a data frame, and from this data frame we can, for example, calculate over here.
So what is the difference between len and count?
Let's have a look.
Len tables,
Yeah.
you see also count, you can use them. What is the difference between them?
So where do you see counts?
Not here, but it's doing the same.
Yeah. So I mean there are different. Usually there are multiple ways to calculate the same thing.
Okay, I have no idea, but I saw it in
Len is, I think,
so
from
Jesus.
Python, and maybe then the count is from the command.
Okay, that's
So in this case, what we see is we have this data frame, and this data frame has closing gates. And what we then do is we convert this into something which can be interpreted as a date. And then we take from these timestamps, we take the year, and then we do a frequency count. Yeah, so this gives us the frequencies of banks that went into default, I guess, over the years. Yeah, so over here we see that in 2008 they had 25 defaults, and in 2012 we had 51. So these are the years sorted to the frequency of defaults. Yeah, so this is just to show you an application that you can just read an HTML file from the internet, convert it into a data frame, and then do some operation, in this case, setting the frequencies. So this parsing, that will be a topic of another week. Then then over here, this is